Yay!
All right, let's go a little bit further with the ideal gas law, and now let's try to compute the mass of air in some typical room, maybe a classroom. So how we're going to go about it is first, let's get the number of moles of air in the classroom. And so we said that this was going to be, PV is nRT, right? Let's use the chemist's way to write down the ideal gas law. So PV over RT, cool. Pressure, this was just an ordinary classroom, so this would be 1 atmospheric pressure. And remember, a common mistake that students make is just to put the number 1 in there for atmosphere, but that atmosphere is not an SI unit. You have to use pascals. That's 10 to the 5th is 1 atmosphere. What's the volume of the classroom? I don't know. Let's say that the classroom volume, let's say it's, I don't know, like 10 meters square, so 30-foot classroom. Oops. Like a 30-foot classroom, 10 meters by 10 meters by, I don't know, let's just keep it easy, 3 meters high. That might be a little high, but something like that. So what is that? That volume is 300 cubic meters. There we go. So 300 cubic meters. R was 8.31, and the temperature is going to be 300. Look at that. So that makes things pretty easy to plug into the calculator. So because look at that, let's just cancel. Nice. So 100,000 divided by 8.31. I don't know. It's going to be something. What is that? That's like 12,000. 12,000 moles of air in the classroom. Okay, what I want is the mass of air in the classroom. So how do I go from moles to mass? This is another skill that's going to be very useful as you go along. And that's to consider the molar weight of the things that makes up air. Okay, air is, what is air? Well, mostly air is nitrogen, something like 80%. So it's about, oops, let's just go ahead and write it down. It's going to be 80% nitrogen, but the form of nitrogen in the air is N2. It's 2 nitrogens kind of buddied up together. And then it's about 20% O2. There's other stuff in there, but not nearly as much. This is pretty much most of it. Because really that should be like, I don't know, 78% and 19%. I don't know. I don't know what it is. Anyway, it's close to that. Good enough. Okay. So what we want is how much does N2 and O2 weigh per mole? And what you do is, let's think about what a nitrogen and oxygen atom are. Nitrogen, it's 7 protons, 7 neutrons. That's in the nucleus of nitrogen. It's also got 7 electrons, right? 7 electrons. But we don't care, because electrons weigh almost nothing. It takes 2,000 electrons to weigh 1 proton or 1 neutron. Protons and neutrons are about the same, as far as we're concerned. So don't worry about the electrons. They're just bits of dust, bits of fluff. So for mass, all you have to worry about is the protons and neutrons. So each nitrogen has 7 protons, 7 neutrons. That's 14. And a nitrogen molecule is 2 of those buddied up. So it's this times 2. Or it turns out that that is, what, 28 nuclear particles. And the way the mole is defined, each of those nuclear particles, a mole of them weighs 1 gram. That's how the mole is defined. So if I've got 28 nuclear particles, then this tells me this is going to weigh 28 grams for every mole. Cool. Okay, what about oxygen? Oxygen is 8 and 8, right? Times 2. So that's going to be 32 grams per mole. Okay, well, all I have to do is for air is just sort of an average of those two, right? So I just take a weighted average. So 0.8 times 28 plus 0.2 times 32. What does that give me? That's like 28, I think I figured it out here, 28.8 grams. So that's 0.288 kilograms per mole. because we're going to need things in SI units. So I have to convert to kilograms. There we go. So that's the average molar weight of air in the room, kind of a combination of nitrogen and oxygen. So that'll work. Okay, well, if I know I have 12,000 moles and I have 0.288 kilograms for every mole, then I'm kind of done, right? I just multiply those together. So 12,000 moles, I'll show you how the units work out, times 0.0288 kilograms per mole. Well, the moles cancel, right? So I just get kilograms. What did I get? 300 is about 350 kilograms. Wow. I mean, that's a little surprising to me. That sounds like a lot. So the mass of air, if you took all the air inside of a classroom and took it out of the classroom somehow and weighed it, it'd be 350 kilograms. That seems like kind of a lot. Because we always think about air as not really weighing anything. That's like 800 pounds of air. That's kind of cool. Okay, on to other examples.